Good evening, everyone, and welcome to this webinar on green building design and certification. In this brief webinar, we will try to unravel some of the questions related to green building design and certification, especially also some of the questions that we have already received on email. And of course, after that, we can also have we'll also have a Q&A. I would request all participants to please keep your mic on mute and so that it does not disturb the flow of the speakers. And later on, when we have the Q&A, you can unmute yourself. So let me share the presentation for today. Is my screen visible to everyone? Somehow I'm not able to see very clearly. Okay, so I hope this is on PowerPoint mode. Maybe Surbhi or Trupti can tell me, or Shivani can tell me if it's all right. Is it clear?
Yes, ma'am. Yes,
okay, yeah, thank you. So yeah, so this is the title of our webinar, and we'll briefly go about these two topics, that is green building design and certification, both of which are related. So firstly, I will be introducing to you this subject, what are the components of green building design and what all is entailed in it. And after that, we will be looking at green building certification, which architect Shivani Salvi will be taking. Thereafter, we'll have a short Q&A session, including the questions that have already been sent to us. And I will finally close with some of the credentials and the work of RUA as well. So to begin with, why we need green building design. So first of all, we are looking at an increased carbon dioxide emission, especially from our country, which is now third in the world in terms of carbon emissions, about 1 to 5 billion metric tons annually. And the effects of this are already reported year on year on the state of the world, state of the global climate by the World Meteorological Organization, which includes, of course, a whole range of issues such as extreme weather events, storm surges, sea level rise, sinking of islands, ocean acidification, which is now 26% more than what it at the time of industrialization, and various other issues which have come up, including forest fires and so on. So the effects of increased carbon dioxide emissions are known, and we have seen the effects already happening throughout the world. When it comes to buildings, what is the role of buildings in this green emissions? Almost 40% of the global greenhouse gas emissions is because of buildings. And this includes the energy consumption during the operational and during the construction of the building, as well as materials that are used. And buildings use water. Almost 12% of global water use is on account of buildings, and that does not account for the water used in the construction or the preparation of the raw materials for buildings, and the solid waste as well that is generated from buildings. Worldwide, you can see that the World Green Building Council statistics say that 39% of all carbon emissions in the world are on account of building and construction activities. Of this, 28% alone is on account of heating, cooling, and lighting of buildings. And 11% comes from various embodied carbon emissions or upfront carbon, that is in the making of the buildings themselves. So in a summary, if we say the built environment is only next to agriculture in its impact on the Earth's ecosystems. Again, I would request all the participants to please put yourself on mute. There are some participants. Thank you. So at Roshni Udyawar and Associates and at EcoSpaces, we believe in a human-centric approach to design, which is not just the use of local building materials, reused and recyclable materials, providing visual and thermal comfort to occupants, and making as eco-friendly a building as possible. That is the approach that we have. And there are three cornerstones to this: resource optimization, that is net zero water, energy, and waste. Circular economy, that is using waste as a resource. So, using materials which are reused or recycled or can be reused, and focus on the environment quality, with both indoor as well as outdoor environment quality for the occupants. So the components of green building design include energy, water, waste, visual and thermal and acoustic comfort, indoor environment quality, vegetation and biodiversity enhancement, and reducing the overall carbon footprint of the building and its occupants. Let's go through each one of them one by one. The first one is energy efficient building, which is the first component of green building design. This involves design of the building envelope in such a way that the building walls, building roof, glazing, all are energy efficient and providing thermal comfort. So this is the first step for making a building energy efficient. The second is use of efficient equipment. And the last is to add additionally the renewable energy, which will make the building almost nearly zero energy. So these are the three components that go into energy efficient design. To a little bit elaborate on what is building envelope design, we analyze the building with respect to its orientation, the site, the form, the materials used on the envelope, and what is the best possible solution. This is for an example of a building in Mumbai. And then we had come up with various design for the facade, the eastern facade specifically, both in terms of the shading, maximum shading during summer. You can see that there are various options that we came up with, and in terms of aesthetics as well as the material used, we had given various options. And so this is a sort of an output of how the building can be designed with respect to both climate as well as energy efficiency. Also in envelope design, there is something called as overall or residential envelope transmission value, which calculates how the envelope is affecting the energy consumption of the building. So basically you calculate either manually or using simulation, and you can see that from the base case of 19.17, by using various methods like high performance windows or external walling materials or cooling systems, and using good daylighting and ventilation, you can reduce the overall energy transmission value and make the building more efficient. So generally, these are the conventional walling materials, and not all of them are actually efficient. In fact, the most commonly used material in urban areas, which is concrete walls, has a thermal transmission value of something like 2.1 watts per meter square Kelvin. And you can see that the benchmark, the dotted green line here showing the benchmark, is actually 0.4. And you can see even materials like compressed stabilized earth blocks, which is A, or D is 0.8, which is AAC blocks, which is aerated autoclaved concrete blocks. It has a good performance. But when you use something like an insulation material, only then you're able to achieve these standards that are given, for example, under the ECBC. So in order to make your building efficient, you need to do various things. And this is what part of the building envelope design is. This shows the standard. You can see that various 0.4 for all building types as under the Energy Conservation Building Code. 0.4 is the standard transmission value or for buildings, external walls. And here you can see what combinations can be possible. So in the earlier case, you saw that the efficient material is something like AAC with insulation. However, you can also have 115 mm thick brick wall along with 75 mm thick brick wall and an insulation, and get a comparatively good U value, as well as, the cost also is much less. So you can see these are the various options that can be worked out depending upon the site and depending upon the material availability. Similar to that is also roof. So you can see 0.33 is approximately the U value for roof that is required under the Energy Conservation Building Code. And, this is not 0.33, but even here an insulation has been used, and this is what kind of value we can achieve. And you can have various other things that can also be done. Here you can see a list of various types of underdeck insulation products and their comparative U values, and some of them are able to achieve the U values that are required as per the standards. Also, one can go for an extensive or an intensive green roof, or use high albedo materials like China mosaic tiles or SRI tiles, and underdeck insulation, or even a radiant barrier such as what is shown over here. Or you can have other combinations, other design inputs like pillar slabs or funicular roofs, and so on. The next component of energy efficient design is efficient equipment, which is not very difficult, but what kind of spaces should have what kind of lighting, and what should be the lighting power density, and what should be the kind of equipment and HVAC design that should be used is also something that is required in green building design. Here's an example, the energy performance index. This is a sort of it's an index which gives you a benchmark for the energy performance of a building. And here, this is for a 1 BHK apartment. You can see that by using various efficient equipment such as geysers or air conditioners or ceiling fans, slowly from 2014 to 2018, the EPI has come down to
पंजाब में बसे हुए ऐसे ही शहर जो टेक्नोलॉजी के युग में रोटी के ऐसे
The next step is making the building nearly zero energy building. So once you have done the envelope and the equipment, then you can have renewable energy in the form of solar panels or wind energy or bioenergy or biomass. And you can, reduce the further energy consumption of the building by using a decentralized renewable energy source within or near the site, or even if it is. An example of that is the Paryavaran Bhavan in New Delhi, which is not only one of the India's first net zero energy building, but it's a net positive building, which means that the energy that it produces it gives more energy to the grid than is actually required by the building. And this is on account of the very good design in terms of the daylighting, as well as the huge number of solar panels, about 930 kilowatt peak, that has been put onto the roof of this building, which takes care of its energy requirements. In addition to that, providing good daylighting, that is visual comfort, is also part of the green building design. The next thing is water management, which involves 3 steps, that is harvesting the rainwater on the site, using water efficient equipment, and using and wastewater treatment. In rainwater harvesting, of course, you can do 2 things. One is storage of the rainwater, or you can put the rainwater in the ground by groundwater recharge, if that is permissible in that area, in that specific area. This involves identifying the catchments, because each of the catchment has a different runoff potential, identifying what kind of channels that can be used, the filters and the first flush device, and finally the groundwater recharge technique, whether it is a trench, a pit, a deep recharge system, or something like that. So every site has a potential for rainwater harvesting. The idea is to use it as much as possible so that there is minimum amount of runoff from the site, and most of the water goes either down or it is used on the site itself. Here are some of the case studies in and around Mumbai that we have done in the past. Water efficient equipment is the second part of water management, which includes using water efficient equipment such as flow restrictors, pressure reducing walls, low flow rates, and sensor based faucets, dual flush systems, using water meter to monitor the usage, and drip irrigation, sprinklers, and so on for the landscape. Lastly, if you have the space and if you have the cost, if you can afford the cost, you can also do decentralized wastewater treatment. We recommend systems which do not use energy and which use plants, and by the by the reed bed system or the roots itself, they are able to aerate and treat the water. So this kind of system is more advisable. There are various types of these systems, and there are even modular systems that are now available and which you can install in if there is space within your site. The next thing is looking at solid waste. So how we can segregate waste, treat the organic waste on site and give the rest of the recyclables for recycling in some way or the other. So having the segregation, even including e-waste, how it can be treated, or it can be, you can have a tie-up with a local company in order to reduce the e-waste. And what kind of system is most appropriate for your site, whether it is biogas or it is a vermicompost, an organic composting system, and so on. Lastly, we look at indoor environment quality. So you can see that there are various things involved in improving the indoor environment quality, that is removing of harmful chemicals, having good ventilation, and plants is one of the ways by which you can do it as well. There are various other techniques, but it involves basically providing a good visual and thermal comfort to the occupant. Carbon footprint reduction, meaning how you can, for example, if you're during construction process, if you're removing trees or you have to remove trees, and how to have additional tree plantation there, or how can you transplant the existing trees post construction back onto the site, or you can even have a tree plantation at another place, which is called as afforestation. So various ways by which you can reduce your carbon footprint. Even the mode of transport, if it's a college or an institution, you can have an electric transportation system, or you can have a cycling system or something like that. Increasing the vegetation and biodiversity. This can be done even in small spaces by having a right mix of various kinds of plants, which attract also various types of fauna and insects, and make the ecology more holistic. So that's it from me, and now I would hand over to Shivani to start the next part of the system, next part of the presentation, which is on green building certification. So over to you, Shivani.
Is the screen visible?
Yes, yes. You can put it on. Yes, thanks.
Hello everyone, good evening. Today we'll be looking at the various aspects of green building certification and understanding them briefly. Green building certification is a third-party endorsement of green building, wherein an assessment of sustainable and environmental aspects are taken into consideration in order to meet the benchmark and standards. The green building certification systems are IGBC. IGBC is Indian Green Building Council. The organization is Confederation of Indian Industry, which is CI IGBC. The type of rating is green new buildings, and the point system is still platinum. GRIHA is a green rating for integrated habitat assessment. The organization is GRIHA Council, and TERI, which is the Energy and Resources Institute. The type of rating is GRIHA version 2019. And the point system is 1 to 5 star. GEM is a green and eco-friendly movement, and the organization is ASSOCHAM GEM. The type of rating is GEM Sustainability Green Certification Program for new building. And the point system is again from 1 to 5. Lead is leadership in energy and environmental design. The organization is USGBC, that is the US Green Building Council. And the type of building is new construction and major renovation. The point system is up till platinum. These are the various common certification systems which are basically used in India. The types of buildings that are covered under green building certification are, we'll be looking at some of the major categories. All the major categories are covered under the various green building certification systems. So we start with commercial, multi-dwelling residential, single dwelling residential, factory, warehouses, healthcare, schools, hotels, shopping malls, and green interiors for commercial as well as residential. The major parameters under green building certification, like under all the categories, these are the major criteria for when you take into consideration all the rating system. These are the major categories which are there. So they are like energy efficiency, water conservation, building materials and resources, IEQ, that is indoor environmental quality, site selection and planning, and sustainable architecture and design. We'll be looking at each of them briefly in the upcoming slides. This is a graphical pattern. So it's represented graphically. It's a comparison of the parameters which are common amongst IGBC, GRIHA, GEM, and LEED. So the water efficiency is around 19 from 19 to 20%, the range. And the energy efficiency is around 20 to 30%, and the building materials and resources credit ranges to around 13 to 19%. We'll be looking at site selection and planning, the first category. So under that, there are various different credits, but we are looking at some of them. So the first one is basically of e-vehicles, so like providing electric charging points, and then maintaining the natural topography and preserving natural topography and vegetation present on the site, and preserving and transplanting the existing trees. Like for heat island reduction, we could use grass pavers and planting trees near the pathways, and also in the parking areas. So you plant trees, or if the existing trees are there, you plant new trees. And for roof, you can use either, you can have a green roof or high albedo paints, high SRI tiles can be used. Outdoor light pollution reduction is basically by having more of downlighters instead of uplighters. And universal design is basically to design a user-friendly, it should be a user-friendly design which takes into consideration differently able people and senior citizens, and making a green building guideline sort of for the users. Water conservation also, there are various types of credits. We'll be looking at some of them here. So having a provision for rainwater harvesting system and groundwater recharge, storage, etc., and having like water efficient plumbing fixtures, that is dual flush and water closets, and taps which have aerators. And management of irrigation system includes drip irrigation and having central shut-off valve and pressure reducing devices. And mainly it's drip irrigation and sprinklers. And again, having provision for wastewater treatment and reusing it for the flushing, landscaping. Water metering includes metering of water consumption and various other water use applications. Again, under energy efficiency, some of the credits have been mentioned here. So having R32 refrigerants for HVAC and the air conditioning systems, having using of solar PV and solar thermal and wind energy, like on-site and off-site, having LED lighting fixtures, which are energy efficient, again having energy efficient air conditioning systems, BEE rated, 3 to 5-star rated, and you also have to carry out basically a whole building simulation to understand the building performance, the building envelope performance, and the energy performance. So an energy simulation has to be carried out, which is a major part of this credit. And again, energy metering for the energy use, various energy use applications, and a building management system. Under building materials and resources, there are some of the credits which are mentioned over here. So segregation of dry, wet, organic waste, e-waste, etc. Followed by organic waste management. A provision of for an organic waste management system has to be made. Under reuse of salvage materials, we have you use the old building materials. So if a building has been brought down, so you use some of those materials like the windows, doors, etc. And materials with recycled content include flash bricks, recycled concrete blocks, etc. Local materials which are locally available near the site at around 400 kilometers radius. Rapidly renewable materials include bamboo and bagasse. And wood-based materials are which are FSC and PEFC rated wood. Those are to be used. And handling of construction waste is like segregating the concrete, bricks, plastic, wood, metal, glass, paint containers, etc. All those waste has to be segregated and reused. Under environmental quality, we have the CO2 monitoring. So CO2 sensors and the monitoring has to be done. Under minimizing indoor and outdoor pollutants, we have the metallic entryway systems to reduce the dust particles from entering the structure. And we have MOV 13 filters for the air conditioning systems, and germicidal UV lamps again for in the air conditioning systems. And then we have low emitting materials, which are paints and adhesives, which are which have a low or zero VOC content. And the carpets have to be basically CRI. They should be CRI Green Label Plus rated. And WPC is a wood polymer composite. So these can be used for paneling and for interior use basically. The indoor air quality management is basically keeping the areas clean and basically covering the ducts and during construction. You cover the ducts and so that there's no dust inside, and there are many other criteria also. I've just mentioned 2 here. And indoor air quality testing is after construction and before occupancy. There is an indoor air quality testing that has to be carried out. Yes, now we'll move on to a tentative. So it's a tentative process of green building certification. How you go about it. You start with the type of project which is there. So you basically know that first, and then under which category, like which we had seen, which category, healthcare, residential, new building, which does it fall under, and followed by the registration procedure, which would take around 6 to 7 days, followed by the green building certification preliminary assessment and green building documentation. That would depend on the stage of the project, the days, like on which stage it is. So accordingly, the time it would take. And here what we see is the submission of preliminary documentation for review. It would be reviewed by third-party assessors, which would take around 30 days. After that, there is the final submission and then a site visit. And then after that, you get the final review and award of rating, which would take another 30 days. So this is basically a tentative timeline and process for green building certification. The tangible benefits of green building are basically represented in a graphical format here. For energy savings is around in the range of 42%, which would be achieved by having an efficient envelope system and efficient materials basically which are used, and efficient equipment and appliances. The waste reduction is around 33%, which would be by having an effective waste management plan, which is to be executed on the site. And water savings is around 25% by installing, and this could be achieved by installing water efficient plumbing fixtures and reusing and recycling waste water, which is generated. The cost of green building is around 8 to 10% that of a conventional building. So the things which would the parameters which would be there which would basically the cost would increase by these parameters. That is the renewable energy such as solar PV, thermal and wind. Passive design, which would be minimum if it is taken into consideration during the design stage itself. Wastewater treatment system and energy efficient equipments and solid waste management system. Here we can see the registration and certification fees in these two tables. So the first one is for IGBC green new buildings. So that's the registration and the certification fees. And the second one is for ASSOCHAM new buildings. So these would be basically differing as per the rating system and the type of building which is there, and mainly as per the areas. So according to the areas and the type of rating system and which building rating system it falls under, it would differ. And also they are exclusive of GST, so that would be additional. That's all. Thank you.
Thank you, Shivani. You can stop sharing. And I think we can have a few questions. So if anybody has any questions, you can just unmute yourself and ask the questions.
Roshni Kaizad here.
Hi, Kaisa.
Hi, I just had one question. One of our auditors some time back had asked about the differentiation in the certification. Like IGBC, I think is an Indian body. I think ASSOCHAM or CII related, right? Then there are the international certifications, maybe the US or maybe European, I don't know. So any difference in these certifications, is it more reputable or creditable to have, let's say, a US body certifying you for green building? Can you throw some light on it?
Yes.
Costing,
sure.
etc.
Yes. So basically, in India, we have 2 or 3 major rating systems. ASSOCHAM is from the ASSOCHAM, which is again like CII, another body, which is one of the oldest bodies, in fact, of the trading organizations. And so their rating system is called GEM, Green and Eco-Friendly Movement. So this is an Indian rating system. And it's fairly simple with 30 criteria and 135 points, which you can achieve and so on. Then we have also the IGBC, Indian Green Building Council, also has its rating system for all sorts of buildings. And this is from CII, the Confederation of Indian Industries, another body. So these both are Indians rating systems. Then you also have GRIHA, which is administered by TERI, and which is basically green rating for integrated habitat assessment. So this is another again Indian rating system. Most of the government bodies are following the Griha rating system. And then we have the LEED. In fact, LEED was one of the first that came to India, and it was at that time, it was administered by CII. Then later on, they changed and had their own rating system. So LEED is Leadership for Energy and Environmental Design, and it also it's an international rating system. So the trend is that all of these are voluntary rating systems. None of them are mandatory. And the reason that people are going for these rating systems is to increase the credibility that they have done green building or so on. So if generally what we have seen is that if it's an internationally known organization like an MNC or something, they go for a LEED rating system. However, that is not compulsory. I mean, even now the credential of both IGBC as well as ASSOCHEM GEM ratings has increased over the years, and even international organizations or MNCs are going for these rating systems. So as such, there is no much, even in terms of costing, we saw that it's not very different. There may be slight variations, but it's not very different. So that you can either go for an Indian rating system or an international rating system. In terms of the difficulty to achieve, I may say that your LEED rating system is probably a bit more stringent and difficult, because probably the kind of standards that they are referring to and all are mostly international, and they do not pertain so much to Indian. So it would be easier for you if you go for an Indian rating system like ASSOCHEM, GEM or IGBC, and how well you do it depends upon the client and the consultant. How many criteria they want to achieve, or how well they want to do it. So it depends again on the person who is going for the criteria. Some people want to just do kind of get a certification for getting a certification, whereas some others want to do all the green criteria and then get a certification as well. So that also depends.
Okay, thank you.
Thanks, Tejan.
Hi, Roshni, can you hear me?
Yes.
This is Shama. I also wanted to ask you regarding the existing buildings, so how can we have this kind of a certification for an existing building?
You can have a certification for existing buildings. So almost all of the certification systems have this category. So you can go for, an existing building rating. Basically, in this, what happens is that on all rating systems, a lot of documentation is required. So you will have to go back and get all the photographs of the site, say pre-construction, at the time of construction, and so on. So only difference between a building that is going for green building certification, which is new or is existing, is depending on how much of information is already there, because a lot of information is definitely required when you go for a certification, and or at least you need to collect it or have a kind of a upload it onto the system. So it is possible to go for certification for an existing building as well, and it's only a question of putting all this documentation together. If it's already green, like I know there are a lot of buildings which are green but have not gone for a certification, so they can also do it.
Okay, thank you.
Yeah.
Hi, Rosni. do go after occupancy certificate any government benefit for green building?
I don't know. Sorry, who's that who asked the question? I can't.
Sorry,
see.
I'm Chirag Shah.
Chirag Shah. Okay, you are from Maharashtra or you're from out of?
I'm from New Bombay.
New Bombay. Okay, so yes, so then great. In Maharashtra, the Maharashtra government has a policy for the Uniform Development Control Regulations that have been recently introduced. They do give incentives for green buildings. So you have FSI incentives as well. So if you are reaching, say, 5-star or or in the case of other rating systems, gold or platinum, then you do get some kind of incentives that the government is also giving for green buildings. So yes, they are there now. And Navi Mumbai, yes, we are doing 2 projects actually in Navi Mumbai.
Which project we are doing in Navi Mumbai?
There are 2 redevelopment projects that we are doing.
Oh, sounds good.
Yes. And we've already received the pre-certification for them. We have gone for ASSOCHAM GEM rating. And I hope that we'll be very shortly, by next year, we'll be able to have the certification for them as well.
During the construction, any visit or any government body will come and check that you are following the rules or not?
No, no. Actually, it depends, because the certification, it depends upon the certification body. So the government relies on the certificate provided by the certification body. So they have approved a few of these certification bodies like IGBC, ASSOCHAM, and some others. So they are there in the UDCER. And if they provide a certificate, then the government considers that as a valid, certificate for achieving the incentives.
Okay, thank you.
Yeah. Is there any other, but anybody else who wants to ask a question? I think I'll then quickly go back to the next part. These are the projects that we are doing in different parts. So you can see ASSOCHAM GEM projects we are doing in mainly in Navi Mumbai, and IGBC certification projects are also, and EDGE certification, which is actually, we didn't share much with you because it's not very popular, but it's also a World Bank based rating system. So as I said, there are many rating systems. We look at a whole offering, which is green building design, certification, and also the certification documentation. Certification also requires a lot of guidance and coordination with all the consultants who are working on the project. So that is also part of what we do. And our team is a multidisciplinary team of architects, planners, academicians, ecologists, botanists, engineers, energy specialists, and technical consultants. And these are the various areas that we work in: architectural, interior, energy efficient, even environmental aspects like watershed. We do capacity building and training. We have some upcoming live offline seminars also coming up, which we will share with you. And our credentials is, we have been in this field for about 20 years. We have various empaneled people in our team, including accredited professionals from IGBC lead, ASSOCHAM. We have people on board who are doing energy simulation and building envelope analysis. I think some of the questions that came through mails, I just want to quickly address. I think, Adil, you had asked about some rural technology interventions. I was not very sure, because most of the certifications happen in the urban areas. Rural buildings we consider are already quite sustainable. However, rural technologies, like, you can definitely have something for wastewater treatment, and even the sustainable building materials which are already there. So we are now going for composite walling systems like the ones that are already used in rural areas, just making them a little bit more user friendly. So there are various technologies, even biogas, biomass, use of biomass can be there, and various other things. I think Shivani has covered this point about what are the actual advantages to customers. Mainly reduction in electricity bill, and you can be sure that you don't know what is coming tomorrow, how high your energy costs will be. And in terms of water supply, also being self-reliant is definitely useful, because there are cities today which are not having any water supply of their own. And we just had again a case of South Africa, Cape Town, which again is going dry, and people don't have water in their taps. How to get certification? I think the process we have already described. And somebody had asked this question, is carbon neutral buildings and green buildings same? So they are not exactly same. They are somewhat a subset here and there. Carbon neutral refers mainly to the energy part, and therefore the carbon emissions. Green building has, other components like water, waste, local materials, and so on. So, I mean, they are part of each other, but at the same time, they can be exclusive as well. So carbon neutral buildings is one part of green building, I would say. And we already shared with you some of the examples, but for each project, what we try and do is to see for that particular project, what is the material that is best suited for the envelope, and how efficient it is, how much energy it can save. This is what we generally do and examine when it comes to green design. So I hope I've answered the questions that we had got through the mails. And yeah, that's it from our side. Thank you.
Thank you. Thank you, Roshni.
Thank you.
Thank
Bye-bye.
you, Rosni. Nice insight.
Thank you. Welcome.
Thank you.
Thank you.
Bye.
Bye.